many thanks to Kenneth for bringing Go Jakarta event over here. All of you probably already are aware of Tokopedia, and I'm hoping that you use it regularly. Tokopedia is one of the largest online e-commerce marketplaces in Indonesia, and we cover everything from physical goods to digital, your first recharges, train tickets, etc. And our goal is to have everything start from Tokopedia. So given that we have such a large presence in the lives of Indonesia, obviously the engineering challenges are also pretty huge, and that's one of the things that I was really excited about before, while I joined Tokopedia about 6 months ago, which is the scale at which the company operates. And very few people around the world get a chance to get involved in something that touches the lives of millions of people. And at Tokopedia, we do that, and we're hoping to do it for even more people. And so, from an engineering point of view, what it really means is that we need to be able to have our services available all the time. They need to be fast, and they also need to be efficient, because we cannot end up, wasting all of the money that we earn on running our hardware resources, right? And so, to that extent, one of the biggest contributors to our efficiency has been the Go programming language. It's exciting to have you here and hopefully share some of the things about Go as well. So to begin with, I would be talking about my journey with Go a little bit before coming over to the actual presentation. So I have been involved with internet companies for more than 15 years, and with internet companies of all sizes, small, medium, large, extra large, and one of the significant events in my career was when I was at Zynga, and we had this game called Mafia Wars. I don't know if some of you have played it in the past. Have any of you played Mafia Wars ever? Wow. So yeah, we had that game, and one of the most exciting things about that game was the player versus player fighting, and it made a lot of money for us, and we wanted to do more of fighting to excite our players. And so we decided to take fighting real time. I mean, Mafia Wars was like a non-real time, just click a web page, button kind of game. And we wanted to make it real time, where users, the players, fight each other in real time while they are logged on to a battle arena. And we decided to do that, and we did not have the technology to do it at that time. And we were looking at several different alternatives, and then that's when, around the same time, Go 1.0 was announced, and we decided to take a look at it because it promised some exciting features. Our game was earlier in PHP, and PHP, as we all know, is like slow and inefficient. So that was one of the attractions, and the other was the performance. And so what we did was we tried out a few solutions, and it turned out that if we spend 1 hour of effort on doing something in Go, we got the highest amount of reliability and performance compared to any other platform. That kind of sealed it for us. And since then, I've done many different things in Go, and I've been continuously impressed with how amazing this language or this development ecosystem is. And that's what I would like to share with you today. It's like a retrospective of all the Go features that I found really exciting for myself. And one of those features is like a standout feature. which is what I'm going to talk about a little more in detail. Okay, yeah. So this is what the talk is about. I've been programming in Go for a little over 5 years, and what I've found to be really interesting aspects of Go. So, like I said, I've been involved with programming for a while, actually since the late 90s, and okay. So, and I've done programming in C and C++, and a lot of programming in PHP, some in Python as well, and on the front end, JavaScript, and I've also had the misfortune of programming in Java. I started programming in Go in 2012, and since then I haven't wanted to program in any other language. And I've had a handful of large Go implementations across 2 different companies. Tokopedia is anyway almost a complete Go shop, so it doesn't really count. And I have my own short list of favorite Go features that I want to talk about today. And out of those features, one of them is exceptional. Like it's not discussed very often, but it has changed things for me quite a lot, and hopefully that's what I want to share with you. It's not exactly a tutorial or a teaching. I'm not here to teach anything, but I'm here to inform you about something which you can then go back and learn about. Okay, so some of the top features of Go, as per in my opinion, one of them is the compiler and syntax. So in terms of the convenience of programming, compiled languages have traditionally been a bit difficult to handle, especially languages like C++ and Java are extremely difficult. Like it's almost impossible to write code in those languages without using an IDE support. Right. The syntax on Go, on the other hand, is very concise, very simple. It has things like type detection and so on, which make it very easy. It almost feels like an interpreted language while you are coding in Go. The error messages that you get from the compiler are very helpful. So if you compile your program, you see some messages. It's very easy to figure out what you did wrong, as compared to, let's say, C++, especially the STL. I don't know. I hope none of you have had the misfortune of programming in C++ with STL, but if you did, then you know what I'm talking about. The language syntax and conventions focus a lot on intention rather than expression. So what I mean by that is, if you look at languages like, say, Perl or Scala, there are many operators or many different what we call syntactic sugars to express something that you want to get done, which is not the case with Go, because while it is very nice to write those short operators or tricky things, it becomes very difficult for people to read that code later on. So Go syntax is very straightforward. You just clearly state what you intend to do, and there are very limited syntactic sugar kind of shortcuts in that. The focus is more on clarity, right? If it compiles, it mostly works, which is, I think this is a property of a very well-designed language, and this is a property that I first observed with Python, where I observed that if I wrote a Python program more often than, say, compared to PHP or C++ or C, it used to work as intended the first time. And the same is the case with Go. If the program compiles, it usually works. I mean, unless I have made logical errors, like I was not clear of what I wanted to do, it mostly works, and that reduces the time to finish, the time to development quite a lot. And lastly, like I was mentioning earlier, right, the performance and reliability that you get with the first, say, 1 or 2 hours of effort on your code is phenomenal. Like, to get the same level of performance, say, in Java or something like that, you would have to spend hours and hours trying to optimize your code and figure out what is the best way to use certain things and so on. So that makes Go a very highly productive language. The next feature that I like a lot is that it's very small. It's only slightly bigger than C, and C is a very concise language. I remember when I was in college, I read the C programming book. Like, I had to appear for a C programming exam, and I read that, Kernighan and Pike book cover to cover in like 2 days or something like that. And that's something that you can't possibly do with, say, C++ or Java or Scala or maybe even Python, right? And so because it's small, it's also very easy to remember, and it's very easy to learn. And all the features that are present in Go are orthogonal and minimal. So orthogonal means that you can combine any feature with any other feature in meaningful ways. So the number of things that you can do with a small set of features is very large, because you can combine them in different ways to make something happen. And minimal means that it does not have too many different ways to do the same thing. Unlike, say, the Perl philosophy, there's more than one way to do it. Was Perl philosophy in Go and in Python, it's more like there's only one good way to do something. And the net effect of all of this is that unlike large languages, there are very few knowledge islands. Like, typically with languages like C++ or Java or something like that, different people have good knowledge of only a subset of the language. There are very few people who would have the knowledge of the entire language. And so when that happens, it becomes very difficult for people to exchange their ideas with each other, because what person A knows might not be the same as what person B knows. The next feature, very well known and celebrated feature, is the standardized formatting. I think I don't need to spend a lot of time on this. This is one of the features that improves the accessibility of code, like by an exponential factor, and that helps in improved collaboration between team members. Like, when you see your code versus your team member's code, it looks exactly the same. When you see code written in your team versus some other team, it looks exactly the same, and then that in turn helps also in giving more access to open source code, because unlike other languages, with open source Go code, you can go and read somebody else's code and you can get more of an understanding of it easily as compared to some other languages. So this is one of the features that I like a lot. It doesn't get talked about much, but I find it really important, which is Go is one of the very few languages that get Unicode and strings right. So when I had one of the very early things that I did was I implemented like my own mini partially binary XML alternative. It was like supposed to be a more efficient XML alternative, and I enjoyed using the C++ string library a lot for that, because you could basically read bytes off of a file directly, and then you could do string manipulations on them, right? And that's very powerful. And that's something that I found missing in Java. Like, in Java, if you want to do anything, any kind of string manipulation, let's say you read a file and you want to parse the first few bytes of a header and then do substring matching or something like that, the first thing you need to do is convert the byte into a string. And bytes are bytes, and strings are actually Unicode code points in Java. which makes things really difficult. And one of the consequences of that is that it's not just inconvenient to program with, it's also inefficient, because any time that you need a string from a bunch of bytes, you need to do a memory copy because they're not compatible. Right? They're different data types altogether. So what Go does very cleverly is that it basically has a UTF-8 representation of a string instead of storing the code points, the 16-bit code points. Partially it's because Rock Pipe was also the inventor of UTF-8, but I think it's a very very well-made decision. It helps writing network programs a lot compared to doing it in Java, or unfortunately also in Python 3. I don't know why they went the Java way. And then Go routines and channels is another, I think it's a pretty well-known feature of Go. It allows you to write concurrent or parallel logic in a declarative manner. So if you've tried writing concurrent programs in Java, I think as soon as you go beyond, say, just attaching the synchronized keyword, things become really messy over there. And personally, I rarely wrote concurrent programs until I came across Go. And I mean, it was required for the real-time game engine that we were writing. And yeah, I mean, the Go routines and channels are based on CSP principles, which is like a very solid computer science fundamental based on communicating sequential processes. And so what it allows you to do is it allows you to write code in a procedural way, like you write code as things happen, but in the middle you can sprinkle some of the asynchronous stuff. So like for example, in Go you can write a function and you can either call it in a blocking fashion, like you invoke the function and then you wait for its return value, or you just prepend the Go keyword in front of that function call or method call, and that makes it asynchronous. It's as easy as that. There's no callback mess to deal with. And then the last one. I mean, this is another. It's probably the most amazing thing about Go's concurrency model, the select statement, because what it does is you have all of these complicated problems in synchronizing parallel processes or parallel execution, right? I mean, you have things like handling the producer-consumer synchronization, or you have things like handling timeouts, or you want to suddenly cancel some execution and so on, right? Doing that with primitives like fork and join and wait, it's extremely messy. And when you add like things like the Java thread model and then thread local storage and all, it quickly becomes extremely difficult to handle. Select is very simple, it is declarative, and the amazing thing is that not only does it make these, like the cases that I listed here, very easy to implement, you can actually combine these patterns together. Like you can have a back pressure applied to a producer, and then have that producer start dropping items once a certain timeout is exceeded and so on. So it makes parallel programming really, really easy and very easy to reason about as well. Okay, so all of these features, they changed my programming capability a lot. The kind of programs that I used to write before I came to Go versus the kind of programs that I used to write after learning Go were like a different level altogether. Like I said, my first production system was a multiplayer game engine in Go for Mafia Wars, and it actually made more than $1 million in 1 year. And then once we got a taste of it, we also wrote some other sophisticated things like a rate limiter for user actions, which had complicated logic based on how much velocity is there for the user and whether they're advanced or not advanced, etc., etc. Things like a reverse proxy, microservice simulator for debugging, load balancers, deployment orchestrator for cloud, auto scaling, and then I even wrote like a custom database, and there's a video on my LinkedIn that talks more about this. But yeah, I actually even wrote a database as well. But so, I mean, like I said, all of those features that I mentioned before changed my ability as a programmer, or the kind of programs that I could write. But one of the features I realized over the years has changed the way I do programming. It's kind of changed me as a programmer. And that's the best feature of Go, which I want to talk about. This feature acts as a stand-in for the user. Like when you're writing a program, you have a certain user in mind. And this feature allows you to proxy that user while you're writing your code. This feature helps improve your documentation. It can guide your program design. Like if you're using this feature, you would tend to produce more well-designed code than if you're not using it. It aids refactoring and debugging. It finds unnecessary or dysfunctional code, and this is not the same as dead code, because dead code is like mathematically not reachable, but unnecessary code is like maybe it is reachable, but you will never reach it because of your runtime conditions, etc. And it gives rapid feedback on performance characteristics of your implementation. So while you're writing code, you don't have to guess whether the code is going to be fast or slow. You can actually get feedback about the performance of the code as you're writing it. So can anybody guess which feature I'm talking about?
Go format.
By the way, how many Go programmers do we have here? Oh, very few. So maybe a lot of what I said felt like Greek to you, but it's okay. Just know that Go is pretty awesome, and if you learn Go, you will graduate to another level of being a programmer. But anyway, so the best feature that I found for Go is actually Go test. So many people know about Go test as like a unit testing framework that ships with Go by default, etc., which is anyway a major improvement over other programming languages, because in other languages, if you want to do unit testing, etc., you have to first filter or shortlist some unit testing library, and then you have to see whether it operates well with your with the rest of your ecosystem, your IDEs or performance testing tools or other toolkits. With Go, testing is part of the development ecosystem. So let's observe how Go test helps in achieving all of those different things, right? First thing is it helps in simulating your users for you. So if you're not familiar with how Go test works, then apologies. But basically, what it does is, along with your actual code, it allows you to write a few test files, and the way those test files work, you can either write tests which can access all of your, say, the private data, or you can write the tests in such a way that they only get your public APIs. So if you use, if you write a test for a package and suffix it with the underscore test in the name, then you get a third-party view of your own code. So you have a test which is acting like a third party or an end user for your code, and then when you're writing your test cases, you can switch your mental state to that of a user, because that test is going to only give you what your public API is providing. So usually in unit tests you have access to everything, and so you can basically test whatever you want to test without being aware of whether the same kind of verification can be done by an end user or not. But this one allows you to check exactly what your API looks like. And so it helps in understanding what symbols you need to export and how your API should look. Then the next thing it helps in is documentation. So Go test actually allows you to write examples, actual running examples, and those examples show up in the auto-generated documentation. So all you need to do is, in your test file, you need to implement functions that start with the keyword example. So if you want to document certain methods, you say func example and then your struct and then your method name. So like if you have a method or foo.bar, you can show an example for it as example foo_bar. If you want to document a regular function, you just say example and then the function name. And then if you want to document use cases, you can say example underscore and then your use cases. And there are many good examples. Sorry for the repetition. Examples of how this works. I think if you go to the documentation of sort package for Go, you can see a lot of these examples. You can see how the use cases have been documented and how certain methods have been documented. So Go test helps you in improving your API design. It helps you in improving your documentation. It also helps you in improving your program design. This is actually one of the properties of doing testing as you are doing implementation. Like in the earlier days, I used to spend a lot of time trying to start writing a program, and then I had no idea of how I would want to structure it and so on and so forth. And then slowly the structure would evolve. When I started using Go test to actually see what my program would look like from an implementer's point of view, I started observing things that I would not observe before. Like maybe there was a function that I wrote which ended up being extremely long, and so it was really difficult to test for, and therefore I would decompose it in such a way that I could test it more easily. And that decomposition would be guided by functionality, because when you're writing tests, you're actually checking functionality, right? And so when you decompose based on functionality, you arrive at a much better design than if you decompose from an implementation point of view, because the important objective is to improve the maintainability of the code rather than ease the first time implementation. Like if you wanted easy first time implementation, we would have written everything in one giant file, like in one giant function, which is convenient for the first time, but it becomes unmaintainable, right? So here's one example of how Go test can help in improving your design. Like if you're trying to design a web app, many times you don't have a good strategy for figuring out how to test it. So one of the ways I like to do it, and it's not the only way. There are many other ways to do it. But what I like to do is I implement the entire business logic as 100% pure native Go code, and then test the entire business logic in that package. And then I add like a data load store package to it, which will basically, so it would fetch data from, say, a database or a file or the network, wherever, and then convert it into native data types. So for this package, I don't need to test any of the business logic. All I need to test is whether I'm getting the data correctly from the database, whether I'm storing the data correctly into the database. And then if I'm implementing, say, a REST service which needs to have HTTP endpoints, then that becomes like a separate layer on top of the core business logic. And so when I implement this, all I need to test is whether I'm getting the requests properly, whether I'm converting the request data to actual native APIs correctly or not. I don't need to repeat the business logic test because that has already been tested in step number 1. So Go test improves your program design significantly. Then refactoring. Again, this is like a standard benefit of having unit tests, right? And Go test provides various different ways of testing. Like there are table-driven tests where you write input-output tables, and then you can just iterate through them and check whether the expected output is what you get from your code or not. And the Go test provides the ability to have nested or hierarchical tests. So you can have top-level tests that check for a particular scenario, and then you can have subtests which basically check more granular functionality. So your use cases are top-level, and then within the use cases, each step is a subtest. And then when you write your test, and let's say your tests don't compile, then you know that there is a problem in, like while you were refactoring, maybe you changed your public interface in such a way that you broke client code. If your tests compile but they fail, then you know that there is some change in your functionality, or maybe you need to change the test to match it, or maybe you need to fix your code to handle that. So testing is one aspect. Go test actually also helps in debugging code. So one of the leading classes of errors in concurrent programs is data races, right? You try to two different threads of execution that are running in parallel. They try to manipulate the same data, and then the output or the final state of the data is unknown. Like it could be anything. So Go has a facility called a race detector, which if you enable the race detector and execute some Go program, it will monitor for these unsynchronized data writes and exactly tell you where those writes happen. And if you're using Go test, you can actually execute your tests in parallel and run them with the race detector enabled, and instantly you have, like, while you're writing code, you're not even done, you're not even shipped to production, and your code is already free of these sources of Heisenbugs. I hope you guys know this term Heisenbug. It is like a bug which is very difficult to reproduce. It happens sometimes, doesn't happen sometimes. You can write very short unit tests that check very specific functionality. You can have long tests that actually test more elaborate scenarios. You can even actually write tests which run entire simulations. So, for example, this chart that you see is basically from data that I gathered by running like a 1 million iteration run simulation on one of the packages that I implemented. It's called Smart Circuit Vector, Smart CD. And this simulation actually compares how Smart CD is performing in comparison to a regular circuit breaker. So I gathered all the data for this from a simulation that I ran using GoTest. Then GoTest also helps in finding useless code. How it does that is basically because when you run your tests, you can also get some coverage output, and it not only tells you the percentage of code coverage, it also shows which lines of code were actually accessed or checked in the unit tests and which lines were not checked. And sometimes your untested lines of code would just be because you did not write enough test cases for that. But sometimes you can, like, especially if your code coverage is really high in the 90s and all, you can see those uncovered lines of code and you realize that, oh, this function is never going to get called in reality, because there is no scenario that I can write a test for which will exercise this function or this code. So Go already doesn't allow you to have extra variables and so on, or import packages that we don't use. This is a way to get rid of all of the code that you're not going to use in your program. And lastly, one of the really exciting aspects of Go test is the benchmarking. So this is, in any other language, my standard way of implementation would be that I would write the program, make sure that it works correctly, and then figure out whether it is fast or not, and if it's not fast, then how to make it fast. Go test actually has a benchmarking feature where you can write your performance benchmarks in a very easy way, and you can run those performance benchmarks as often as you like. And so, like while I was developing that the database that I mentioned earlier, I used to run benchmarks like essentially on every commit. Before doing a git push, I would rerun the benchmarks and make sure that I have not introduced a performance regression throughout the development phase of that application. I knew exactly where my performance bottlenecks were and whether to address them or not. So there are a few examples of what the benchmarking can do. It can tell you how fast your functions are. It can tell you how your function scales in a multi-core scenario. So often when you run programs on a single core, you will get some performance metrics. When you add 2 cores, you would expect your program to run twice as fast, but it doesn't run twice as fast because of synchronization issues or other things. With Go test benchmarks, you can actually see how your application is scaling as you add more and more CPU cores. And then you can actually use the infrastructure to also figure out where your program has bottlenecks. For example, you can get a CPU profile, or you can get a memory profile to show where you are consuming a lot of memory. And that way you're always aware of your performance. This is a video that I wanted to show about one typical session which I used to have while implementing that database, where I could run the unit tests, run the benchmarks, analyze the profiles, and find bottlenecks, all in less than 2 minutes. This video is personally it can't be played because of some data format issues, but you can also see this video in my other presentation that I was talking about. So in summary, Go test is like a programmer's assistant. It's not just a unit testing tool. It's actually like your assistant, which is available at all the stages of application development. It's like Jarvis for Iron Man or Alfred for Batman, and it also happens to run unit tests. All right, so that was the best feature of Go that I think. Thanks for having me.
Selamat malam semua. Terima kasih untuk kedatangan ke sini. So at some point in the future, I will do these talks in Bahasa. I've been here a few years, but my technical Bahasa is not good enough to do these presentations. But anyways, thank you all for coming. I really appreciate it. If you haven't been here before, I see a lot of faces I don't know, but Go Jakarta is a monthly meetup group focused on the Go programming language. By the way, I'd like to thank Tahir. He did a really great presentation. It was really awesome. So just about me, former CTO of Multiply. I'm the CTO of Broncos. Broncos is a company focused on fixing electronic payments here in Southeast Asia, but specifically in Indonesia. Basically, I just want to get into it because we're kind of running a little late here with the time. Do we already have the slides up? Because I have slides for all these things. I come prepared. Awesome. It's like cut off. It's not good. Okay. Whatever. So big thank you to Tokopedia for setting this up. This is actually the second Take a Break that we've done with them. The last was about a year ago. So just want to say that if you are not a member of Go Jakarta, please join us on meetup.com. We've also got a really active Telegram group and a really active Facebook group. And our website, which is not very helpful, is gophers.id. But it's pretty cool. So Go Jakarta is a monthly meetup group focused on, oops. Sorry, I'm not used to this. It's focused on Go, but we're also focused on kind of topics surrounding Go. So, like for instance, last month we did a topic on using Go with containers. There's been other presentations at previous times about comparing Go to other programming languages and stuff like that. So we're not entirely about just Go, but everything kind of around Go as well. My slides, at least, are here at gophers.id/slides. You can actually do Go Get. So when I do my presentations, I typically do like live action stuff, but since we're using the slides from, I don't have access, so I'm not going to do live demonstrations of code today, which I apologize. But otherwise, oops. So, just real quick, I don't see, did Dimas come in or not? No? Okay, so Go Jakarta also, we're always looking for presenters. Our hardest thing to find here in general is presenters. I don't know why, but it's really hard to find people that want to talk on Go, and I understand that's because a lot of people here, a lot of developers are new to Go. But don't worry about it. If you're, the point is that we really need speakers. So if you would like to present, please contact me. I'm very easy to get in touch with. That's my email and my phone number. And also here's Dimas's contact. He also helps arrange speakers. We also have Randy over here wearing the Gopher t-shirt. So if you are interested in speaking, or if you have a location that we can use for our meetups, please let me know. We are also looking for locations. But that's become a little bit easier in the last few months. Okay, next month we have a presentation on the 20th. It's going to be in South Jakarta. I already have the location, but we're not announcing it yet, but the date is definitely February 20th. So my presentation tonight is going to be on running Go everywhere. So kind of what I want to help accomplish is that make 2018 for you the year of Go, because Go is basically the most ideal programming language in the world today. It runs everywhere, and I'm going to basically go through that on some of the qualities on why you want to choose Go. And I'm going to basically demonstrate, sorry, not demonstrate, but I'm going to basically give a quick overview about how Go runs in the browser today. If you're not aware, it can actually do that now. So, kind of one of the things that developers Hello? All right. So for a while, developers have kind of sought the ultimate holy grail of programming environments is that, we want to write code once, and we want that code to run everywhere. And we don't want to have to make a bunch of different changes to it in order to do that. Now, some of the other things that we want with that is that we want the code to be fast, we want it to be native, we want it to be type safe, things like that. And this is really what developers have been looking for years. Not really years, but decades. I know going back to the 1960s, this is basically what they've always been looking for. So there's been a bunch of different approaches to this over the years. You might be aware of them, which is, you've got Java, ActiveX, Flash, you've got, Salt, you've got JavaScript, backends for LLVM, or you've got other kind of, compiled language approaches, which is, things like hacks or whatever. The problem with these previous approaches is that they've all had really serious trade-offs. They've either been extremely slow, they're extremely difficult, and they just otherwise don't work the way they're supposed to, right? And it kind of comes down to these, is that developers have not adopted these mechanisms. And when I say developers, I mean we as developers have not adopted these previous technologies because basically it's been too complex, it's been proprietary, there's not really been a standard, there's been a lot of developer fatigue around it, and meaning that something that works today kind of goes out, doesn't work tomorrow kind of a thing. And for the other kind of reasons of platform exclusion or performance issues. For instance, you can't run JavaScript natively on iOS in the same way that you can run it on, let's say, Android, because Apple won't let you package your own JavaScript VM to run JavaScript code on iOS, right? So, or they won't let you run your own Python interpreter, or they won't let you do a bunch of things. It only allows compiled code. So, because of that, you've basically not been able to do it until just basically recently. So if you're not familiar with Go and kind of the characteristics of Go, is that Go is almost already an ideal programming language and programming environment to begin with. It's already machine compiled, it's very, very fast, it's very, very efficient. For those of you who are new to Go and have not been using it before, these are kind of the things you may not be aware of. But what's really nice about Go is that it's, you've got fast single file deployments. So meaning that your entire application compiles down to a single file usually. And it's unlike other approaches like ActiveX or something like that. It's open source, it's well documented, and it's easy to interface with other programming languages, compared to other ones. The only thing that Go has not had is that there's been one major platform missing, which is the web browser. You haven't been able to run Go code inside of a web browser. However, we're now in 2018, and this is now a possibility. We have now a standard called WebAssembly. Anybody here familiar with WebAssembly? Yeah, okay, so 3 people out of 200 people, so 1% of the audience. It's not bad. So, if you're not familiar with WebAssembly is a new standard. Now, unlike other standards that have been approached by the developer community, is that unlike other approaches, it's here now. This is not something that's going to be here 5 years from now, but WebAssembly is now available today, and it's the accepted standard way to move forward with building code inside the browser. Okay, WebAssembly is basically a different kind of JavaScript, but it's been agreed on as a standard by the entire web community, and it's available today in Chrome, Edge, Firefox, Opera, all the major web browsers already support it. And it's available already on more than 85% of web browsers today. Now, WebAssembly is basically a machine code that runs in the browser instead of JavaScript. So it runs on the same VM as JavaScript, but it's already pre-compiled machine code. Okay? without getting into that, the point of this is that if you have a language that can compile to WebAssembly, basically you can run it in the web browser. Now, until November of last year, there were only a few languages that could compile to WebAssembly. But there is now an experimental Go port, an experimental Go branch, that actually compiles to WebAssembly, meaning that Go now will compile natively to every single platform and every single machine language that exists out there. So if you want to compile Go code to WebAssembly, you can do it today, right now. There is nothing stopping you from writing code that runs in the web browser at efficient machine level speed right now. And this is literally all you have to do to get your Go source tree to basically be able to compile WebAssembly. Now, I'm going to be very honest, it's not easy to do right now. There's a little bit of like work involved, more than basically, writing JavaScript or something like that. But considering if you wanted to write, C++ code, or if you wanted to write some other language and run that in the web browser, the complexity involved in getting this done is very, very small, right? I mean, this is all that basically needs to be done to get your Go source tree compiling to WebAssembly today. So the thing is that you now basically would have one Go build chain that's able to build to iOS, to Android, to everything else natively right now. All right. So this is where I typically get into my examples of like code and all of this, but keep in mind that these slides are available online. It's gophers.id/slides. It'll redirect you to the GitHub page. All of the code I have here is a working example. You can download it, you can run it yourself if you're interested. So given this very simple example, I'm going to basically demonstrate how you would run it and generate it for every single platform. So I realize that everybody here is pretty new to Go, so I apologize if I'm going kind of over people's heads, but this basically is all that you would need to do to run this same piece of code. So this very small piece of code, which is literally just hello world, will run the same, and you can compile for basically any architecture and any machine by just basically passing the Go OS and the Go Arch constants, environment variables, not constants. But basically, cross-compiling with Go is easier than any other programming language on the face of the planet. All you have to do is just specify before you type Go build, is you just specify the Arch and the operating system. 386 Linux, 386 Darwin. You can just basically combine these as any way you see fit, and it will compile it directly to the machine code, right? Basically, if you run this, you would get an executable, the name of which is here. This is -O is the for output. By the way, if you branch of Go that I showed on the previous slide on how to get it, if you build it like this and you output the file, you will get basically an executable, a WASM executable that will run exactly the same way. That is machine independent WebAssembly code. Okay. Now, you can also run this if you have if you export this magic path, which is whatever your path to Go is. Typically, you put that on user local Go, put it in the MIST WASM directory. If you put this on your path and you can actually run the WebAssembly code in the same way you use Go run. Now, for those of you who are completely brand new to Go, you may not be aware of Go run. Don't worry about it. It's something you'll learn. But Go Run basically will build and execute your code and then runs it natively. And it will actually run it using the it'll actually use a JavaScript interpreter to run it. You can test your code in the same way. You can do Go test. You can do all of that kind of stuff in the exact same fashion for your WSA built code. Okay, so this here is the magic that basically allows you to load that WSM assembly in the browser, your Go browser. Now, it's a little more impressive when I do an actual demonstration with a web browser, but I assure you that this is correct and it works, and you can download it from my slides. It works the same way. But all you have here is just some magic WebAssembly loading, which is being provided by a WSA exec. This is an accompanying executable file that's part of the Go branch, the special Go branch. But it will fetch the file for you. It will compile it inside the browser, load it, and run it. And once you click on this button here, this HTML button, sorry if you're not very familiar with HTML, all this does is this basically just loads some JavaScript, and then it has a single button that when it clicks runs the run function, which is defined in WSM exec, but all it does is it just loads the main.main package func from Go, and it will basically just run it. And the output from that, if you go back to this is just literally the hello world example in Go. Basically what would happen is that the output gets sent to the output in the same way, okay? So the thing here is to really not get too caught up on the technicality of what's necessary. Obviously, it's a little more complex than I make it out to be, but the point is that as developers, as of November 2017, we have something that has never existed before in the history of web development and the history of software development. We have one single compilable language that will compile to fast, efficient machine code in the exact same way across every single platform, across every single machine, and is usable in a way that's never been done before. And this is what's so great about. This is how to actually serve the files. Sorry. Okay. So this is really what's great about Go and about what's been happening with the Go programming language that you don't see in other programming languages, is that there is no other programming language like this today. Even the other programming languages that will compile to WebAssembly, JavaScript, etc., blah, 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 which do compile to WebAssembly, you can't use it in the same fashion. You can't use it without carrying around some kind of VM or some kind of interpreter with you, like the JVM or something like that you don't need with Go. Go is the only programming language that exists today that will compile to native machine code and to native platform code for the web browser, for ARM architectures, for AMD 64 architectures, etc. And the thing is that even though it took me, I'm kind of an expert at doing this stuff. It took me quite a bit of time to get this set up in a digestible format for you. But the reality is that this is only going to get easier and easier with Go. Before the end of this year, I can almost guarantee you that this WASM port will be, this WSAM branch will be merged into the main Go source tree. Meaning that before the end of the year, Go will be the only language that truly supports true cross-platform behavior in a way that's never existed before. So the thing is that to think about is that because Go actually compiles C and C++ code, think about that, is that Go is going to be the easiest way to get C and C++ libraries deployed inside of a web browser. Does that make sense to people? And that's kind of a weird thing if you think about it. It's just that this just is really a new thing. I mean, it hasn't existed before, and it's really almost like, God, I wish this existed 20 years ago. But it doesn't, it exists now. So what I want to do to start off the year, for those of you who are completely new to Go, who are completely new to Go Jakarta, is I want you to think about the possibilities about what you can do now that was never possible before. The code that you write that runs on the server, that runs on the desktop, can run in the browser in the same way. It can run on your iOS device, okay? Like, I have written a bunch of code before that runs exactly the same as runs the same as on my Android phone, as basically runs on the server. And now you can write that same exact piece of code that will run in the web browser the same way. And while there is a little bit of hoops that you have to jump through today, it's going to completely disappear probably within the next 6 to 9 months, or even sooner, depending on how fast the Go team moves at Google, basically. So just keep that in mind. Think about like the new world of possibilities that didn't exist before. You could write, you could hypothetically write today in language. So just think about those possibilities. One of the things that one of the things that I had as a developer is that it was really hard for me originally when I got out of college, to kind of quote unquote prove myself, because everything that was worth doing had already been done, right? And anything that wasn't worth doing, or anything that basically couldn't be done, hadn't been done, right? Because it just wasn't possible to do, right? So this, for me, it really reinvigorates me. It makes me really excited to be a programmer again in a way that I haven't felt in 15 years, because it's just never been done. Like, I mean, we're pioneering things in ways that have never been like understood. Okay, so just to give you a quick example, like of another like off-the-shelf, off-the-cuff example. If you guys are familiar today with how cryptocurrency is going insane, and it's big and all of that, okay? The Lightning Network, entirely written in Go, okay? Anybody here know about cryptocurrencies or any of that stuff? I don't want to get into cryptocurrencies. I really don't care about them. But the point is that like the Lightning Network is written entirely in Go. As of November, you could compile the Lightning Network and make it run entirely inside your web browser, natively in WebAssembly. Huh? No? Nobody cares? All right. It's okay. It's hard to get people like excited about this stuff, because it's really not tangible, right? Anyways, so I just want to say thank you for coming out. This has been a really great event. It's really big, it's awesome. And so thank you all for coming, for braving the Hujan Banjir to get here. Those of you who have ordered t-shirts, if you wanted to, or if you wanted to buy a t-shirt, we have Go Jakarta t-shirts. Tahir, where is he? Did he leave? Okay, yeah, so over there, I have a shirt for Tahir. So, where is Tahir? Is he here? I don't see him. Oh, there. Okay. I have a T-shirt for you too, by the way. So if you care or whatever, I'm not trying to pimp these or whatever. We don't make any money from this. Oh, they don't have my picture on this. Oh, whatever. They took my picture out. No, I'm just kidding. No, so we have stickers. So we have free stickers for everyone. Little tiny Gopro stickers. They look like it's basically the gato gotcha, yeah. Gotcha. Yeah. So it's our little version of the Go Gopher. We have free little stickers for that, and then we have some bigger ones that cost a little bit of money. And then we've got more T-shirts if you guys want to buy it. You can see a couple people that are wearing the shirts already, so thank you very much. But I want to say thank you a lot to Tokopedia, to Tahir for hosting the event, and